So we are supposed to create a transformation matrix that connects Z diagonal basis to the Sx diagonal basis. And we need to show that this is consistent with this general result. Okay, so let us try to understand what do we mean by Sz diagonal basis. So we remember that if there is an operator, we need to represent it in some basis. For our case, the states I and j are nothing but 0 and 1 or plus and minus. So there are four parts. One that is 0, S Z, 0, 0, S Z, 1, plus 1, 0, 1. And we know that Sz operated on 0 gives positive eigenvalue h bar to 0. And I said what is negative eigenvalue this, and also 0 and 1 are orthogonal to each other, so we can write it like this. This can look like the matrix can write it for simplicity. Yeah, so we already know this is Pauli matrix. Yeah. So I gave a just quick overview of how to go about this. So these states 0 and 1, they are the eigenstates of spin z, and when we represent the spin z in this basis, they are 0 and 1, it looks diagonal. So we are asked that how can one go from the Sz diagonal basis? That means how can I go from state 0 to Sx diagonal basis? That means I am basically going to move to spin x eigenstates. Negative eigenvalue, which we know what do they look like. They are superposition of 0 and 1. So we are asked basically that there is a matrix that operates on state 0, and in return it gives me this type of function. Okay, so let's start with a guess. Let's say this is A, B, C, D. Then if A, B, C, D operates on state this, I should get something like this, because when you sum this up, it is 1 0 plus 0 1, which is here. So, okay, so this gives us, there is A, and yeah, and there is C, which is 1 by 2 1 1. So from this we can conclude A is 1 by square root of 2. Yeah, okay. And C is also 1 by square root of 2. Okay. Also, we need to see that if we want, it should give me 1 by square root of 2. So this one is cd plug on 0 and 1. This will minus 1. This gives us b, and d equals to that's minus 1. So b is 1 by square root of 2 and b is equals to minus 1 by square root of 2. So the u looks like this. Is 1 by square root of 2 is 1 1 is 1 minus 1. Okay, notice these are just how do I write? This is basically 6 plus this is minus eigenstate, right? Written in column form. Okay, fine. So we found the matrix that can take us from one diagonal basis to another diagonal basis. And we need to verify something else also. If I want, can decompose this into a different form, which looks something like this. Okay, we can verify that this can reproduce this matrix, and this is nothing but sx plus, and this is sorry, okay, okay, 0 minus this. So yeah, this is basically summation of these type of forms. Or as they have written, generalized form, this we are so going from SZ diagonal basis to SX. You see it here also. SZ to SX. So we have proved this.